Hello everyone. In this week, we will introduce the chapter of logical agents. So in this chapter, we will introduce how to design agents that can form representation of a complex word. So by using the inference process to get new representation of the word. So then the new representations are used to deduce what to do of the agent. So the title of this chapter is Logical Agents. So in which obviously we will cover some contents on logic representation and inference. So let's begin with the reason of why we need logic. So generally, there exists some limitations. There exists some limitations in the problem-solving agent we described in chapter 3. Okay. So in that chapter, we described some problem-solving agents, but they are pretty limited in coding each possible state of the search space. And usually, the time complexity of some searching algorithms, such as the BFS, is exponential in the number of states. So this is described on the complexity of the searching algorithms. Besides, the problem-solving agents cannot perform inference in purely unobserved environments. Then, we want an agent that can reason similarly to human beings. So this may be achieved by designing a knowledge-based agent. Which can perform inference on internal representation of knowledge. But how can we ask a knowledge-based agent to perform reasoning? So first, it should maintain a knowledge base. It should maintain a knowledge base, or KB in short, which contains a list of sentences that are known to the agent. So we can see the KB is a set of sentences in a formal language. This formal will be defined by some syntax of logic. And second, there must be some ways to add new sentences to the knowledge base, and a way to query what is known. This is tell, and this is ask. Okay, so the standard names for these operations are tell and ask respectively.